So let's look at how to use while loops in LabVIEW. While loops is a type of a statement that are called control statement. And these statements basically are present in every programming language, and since LabVIEW is a programming language, although the programming is done graphically, hence while loop, for loop, they are present in LabVIEW as well. And as I said, it's the control type of statements that are present in Python, C, even BASIC, and Java, and every other programming language, MATLAB that you're going to study next. While loop is present, for loops are present, if statements are present. So let's look at how to use while loops. So basically the idea of while loop is, as you can read in the tutorial, is um, basically you are running some statements, you are performing some function, and you do not know, and the function or those statements are based on some condition, that when the condition is going to met, or as long as the condition is not met, you have to keep executing them and keep performing some operation. And since you do not know when those conditions are conditions are going to be met, in those situations, you use a while loop. So in LabVIEW, the while loop is under programming, structures, and you can see while loop is here, and you are also going to study for loop. So both for loop and while loops are, and those are in the block diagram, remember, because while loop you are going to use to create the logic of something that you're presenting in the front panel. So they are not in the front panel, they are for creating the logic, hence they are in the block diagram. So if you put the while loop, it's going to be like this, a box, and you can expand it, you can make it as big as you want, and then click it. So this is the while loop. This is the iteration, loop iteration, as you can see, and this is the loop condition. Now what is the loop condition? When you want the while loop to stop. So you can make it keep running as long as the condition is true or false, or you can make it stop when the condition becomes true or false. So if you right click on that red button, then you can see what condition do you want. Stop if true. So as long as the condition is not met inside the while loop, it will keep on running, but only when the condition becomes true, then it is going to stop. Or you can choose continue if true. So as long as the condition is true, it will keep on executing the statements that are inside the while loop. And once the condition becomes false, then the while loop is going to be stopped. Okay, so you can choose either of the conditions. All right, you have Boolean palette because Boolean functions are closely associated with while loop. Uh, because whenever you are using some conditions, generally you use some sort of Boolean function or some sort of comparative function, like we studied comparative functions, like something is greater than something or something is equal to something, or you are using if this is greater than this quantity and this is less than this quantity or this is equal to this quantity. So when you use the Boolean AND, that means both conditions need to be satisfied in order for the condition to become true. Now you can also use OR. That means even if one condition is satisfied, the condition will be true. But if both the conditions will be false, only then the whole condition is going to become false. So as I said, the Boolean palette is here because Boolean functions are closely associated with the creation of condition that you may use to decide when the while loop is going to be stopped, or how long the while loop should be executed. Okay, if I go back to our tutorial and you see the simple function, the simple program that you are basically asking user to give an input number, integer, between 1 and 10, and then your program is basically generating a random integer between 1 and 10. And user is entering the number. So as long as user does not enter the correct number that is being randomly generated by your program, the light will be off, and then user will keep on entering the number. But as soon as the number is going to match the number that is randomly selected by your program using the random number that we discussed right here, random number generator, then the light is going to turn on and the program is going to stop. That is, the while loop will stop executing. So how did I create this program? Observe how simple it is. So this is your while loop, like I showed you. User input is inside the while loop. Remember, anything that is inside the while loop is going to keep on running as long as while loop is running. So observe that you are generating the random integer outside the while loop. Now, here there is a small mistake that I made actually. I'm using the nearest one, the round off to nearest. But remember, round off to nearest is going to generate, it's going to round it off to from 0 to 10, because whichever is the number closest to the value that is generated by this product, which will be between 0 and 10, it is just going to round that off. So actually this program, you will have to choose from 0 to 10 instead of 1 to 10. If you have to go with 1 to 10, then basically you will have to use numeric, and you have to use round towards, let's see, which one is this? Round towards what? Let's look at the label. Round towards infinity. That's what you will have to choose. Round towards infinity. That means round towards the next integer. So if it is like 0.2, instead of rounding it to the closest integer, it is going to round towards the next integer and it's going to become 1. So in this case, it is going to be between 1 and 10, but irrespective. If you're going from 1 to 10 or you're going from 0 to 10, irrespective of that. So one number is going to be generated by your random function, and that number is going to be from 0 to 10, right? And now that number is going in the while loop. Now, if you create this function inside the while loop, then it is going to be an error, because every time while loop is going to run, it is going to generate a new integer. So make sure you have to be very clear about how you're making the logic. Anything that needs to be executed once, that has to be outside the while loop. Anything that needs to be executed as long as while loop condition is not satisfied, that needs to go inside the while loop. So the only thing that you need to keep asking user to keep entering the integer between 0 and 10, as long as that number is not matched with the number that is being generated, then only the user input is inside the while loop, right? And then we're going to use the comparative function equality, and we are going to check if the user input and the randomly generated number are equal to each other. So as long as they are not equal, the output of this equality box is going to be false. And as long as it is false, it will keep on running. Remember the condition? If it is red, that means stop if true, or in other words, keep running as long as it is false, and only stop if the condition is going to become true. So this loop is going to keep on running as long as this condition is not going to met. And when this condition is going to be met, when user is going to guess the correct number as what was generated by the random number, right? And once it will be met, the condition is going to be satisfied for the while loop, and it is going to be stopped. And as soon as it will be stopped, whatever is this condition, either false, of course it's going to be true at that time, that true condition is going to be travel to the LED, and of course it's a true condition, it's a 1, so LED is going to turn on. So as soon as while loop will stop, condition is met, these two values become equal, and the numbers are matched. So this is how we are using while loop to create this a number guess game, what you want to call it. Okay. And I introduced Boolean functions as they are used very close to while loops. And I showed you those Boolean functions, and those are the Boolean functions that you have also used in PSpice, right? So you have not, and, or, three basic Boolean functions, and then NAND, NOR, NAND, XOR, and XNOR. Those are basically advanced Boolean functions that are based on these basic Boolean functions. And once again, we discussed this in PSpice, but this is a small, brief explanation of all these Boolean functions or Boolean gates. Okay. Now let's see how you can use those Boolean functions. So you have two dials here, and the idea is whichever dial has the higher value, the LED corresponding to that light is that dial is going to turn on. So you're going to put two dials. Each dial has the range of 0 to 10. And remember, once again, make sure anytime you're using a dial, you're using a meter, make sure you adjust the range based on the program condition. So if you remember, one of the exercises were that you have to convert the Celsius into Fahrenheit, and the Celsius were given using a dial or a knob, and I asked in that program to give the centigrade or Celsius temperature from 0 to 100. Now the standard values are from 0 to 10. So again, most of the students, of course, did change them, but some of the students, they just left it from 0 to 10. And likewise, thermometer, when centigrade or Celsius are going from 0 to 100, then the equivalent Fahrenheit temperature is from 32 Fahrenheit to 212 Fahrenheit. And likewise, you have to change the range of the thermometer. And I mentioned it to you, you can just click on these scales, and then you can just use the new range, and it's going to auto adjust basically. Or you can just right click on it and go to scales, and then you can change it. In any case, so in this one, whichever is higher, the light will turn on. And observe, very small, very straightforward program. You have two dials, and I'm just using the greater block. So if A is greater than B, you have two LEDs. The output of the greater block is going to be true. So the top LED is going to turn on, and the bottom LED, although the same true is flowing through this wire as well, but you have a NOT gate over here. And the NOT gate is going to turn true into false, 0 into 1, 1 into 0. And hence the bottom LED is going to be off. And when A is less than B or B is greater than A, then the greater box is going to give you false. Upper LED or the LED associated with A is going to be off, and that 0 is going to travel through the NOT gate, which will become 1, and the LED corresponding to the B will turn on. Okay. All right, let's look at this exercise. Create a program that can generate random integers from 3 to 8. Your front panel will have only one numeric indicator to show random integers. Okay. So as you did, one of the exercises, which was this exercise right here. Create a program that randomly generates one integer, 0 to 10. Front panel will contain only one element, which will be numeric indicator. Exactly the same way, this is another exercise that your front panel will have only one numeric indicator that will show you a random number from 3 to 8. So instead of going from 0 to 10 or 1 to 10, now you have to go from 3 to 8. So one way to do this program is to use a while loop like we have, and check a condition inside a while loop. For example, generate a number from 0 to 10, a random integer, like you did in the exercise that the previous exercise. And then check a condition inside while loop that if the number falls between 3 and 8, then stop the while loop. And then whatever number you have at that time, that number is going to be displayed. Right? So this is one way to do the program using while loop. And actually, you can create a program in another way. You can think about it, how you're going to create it. But since we are studying while loop, it will be better if you just use while loop to create this program so you can get some practice with while loop. But if you create in any other way, it will be fine with me. But think about it, how you're going to create the program using while loop. All right, look at exercise 10. You have 3 dials, and each dial range from 0 to 10. Choose 3 LEDs, 1 for each dial, and then you have to create a control system such that whichever dial has the highest value, the LED corresponding to that dial is going to be on, and rest of the LEDs will be off. So similar to this, but think about it. Read it and think about it. So you have 3 dials, 3 LEDs, 1 LED corresponding to each dial. And let's say dial A has the value greater than B and greater than C. Only then dial A, LED corresponding to dial A will turn on. Dial B, if its value is greater than A and greater than C, only then the light corresponding to dial B will turn on. And likewise, dial C, if its value is greater than B and greater than C, greater than A, only then it will turn on. So remember what I'm telling you here, greater than one of the dials, and greater than the other dial, and. Think about it, and. So that's a logical and I'm talking about. So it has to be greater than both of them, and then the output should be true, and that output should be going to the light of that dial. Okay, so I'm giving you a hint over here as well that I explained. So think about it, how you're gonna draw, how you're gonna design this exercise. Okay, exercise 11. Something that you did in PSpice, you created a logic circuit, and basically A, B, C are 3 switches, and you're gonna put an LED for X. So 3 switches representing A, B, and C, an LED representing an X, and then you're gonna go through these conditions. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And then for each of this condition, which you will enter using switches, you will check out the output. What is the output? Either 0 or 1, and you're going to fill out this table. Okay. So once you do this exercise, this is what I want you to do. Of course, in the front panel, you will have 3 switches. So in the front panel, you have 3 switches, A, B, and C, where C is the least significant bit, and A is the most significant bit. And then you have X, right, which is LED. So you have 3 switches, A, B, C, and then you have X, which is LED. And I want you to go through, all this table, this truth table, and see if the output is low or high, and you create this table in the front panel. So either you type it, so let's say A, B, C, and X, right? And then you type it so that whatever you observe, let's say for 0, 0, and 0, you observe 1. So go ahead and type 1. So you have 3 switches, you have LED, and then you will have this table in the front panel. Or you can also use these tables. So you also have a table over here. If I put this table here, table looks like this, right? Let me see, you can do it like this. So if I do A, B, C, and then I expand this to put X. X. Okay, and then you can just fill out this table. 0. I was hoping with tab is going to work, but it's not. 0. Let's say if it is 1. I don't know if it is 1 or not. I'm just giving you an example, right? 0, 0, 1, 0. Okay. All right. But once you fill this table out, make sure you do one thing. Let's see if it will work. Because if you close the program, the table is going to be erased. Now, if you type it in, it's not going to be erased. So I don't care. I think it will be better if you type it in. But if you're creating table, do this thing. Hopefully, it's not going to erase. Do this thing, right-click it, and then go to data operations. and then choose make current value default. So if you're using the table to create this truth table, right click. If you have typed all the data, right click and do make current value default. And then save your program. Let's say if I'm just showing you as an example. So let me go ahead and save this program. Let me go to just in the documents, and I'm going to save this program. Example. Okay. And then I'm going to go ahead and close this. So once I open this, observe this table is intact, right? So it did not erase the contents of the table. Now, if you don't do the current values initialize, if you just leave it by default, which is basically erase all the values once you restart the program, then even if you put any value here, it is not going to show any value. So make sure if you're using this table, always do right click, go to data operations and make the current data default. Or you can just type the table, okay? So if when you're doing this exercise, please keep that in mind. And in the next video, we're going to discuss matrices and arrays.